Hey guys, today we are going to solve some equations involving logarithms, and we'll start with the property of equality for log functions. So that property says if two logs are equal, so that just means there's a log on one side and a log on the other, like this. Log base 5 p squared minus 2 equals log base 5 of p. They are equal because there's an equal sign between them. And they have equal bases. Okay, so these two have, first of all, they have an equal sign, so they are set equal, and they have equal bases. Both of them have a base 5. So if that's the case, the two logs are equal and they have equal bases, then the arguments are equal. Okay, so that means that p squared minus 2 is equal to p. Okay, so I've got two logs set equal to each other. They have equal bases. That means these two arguments are equal. So p squared minus 2 equals p. Okay, so I can just drop those logarithms, or what I can always do is do a base 5 on both sides. So it's 5 to this power equals 5 to this power. And that 5 and log base 5 cancel on both sides, and I get p squared minus 2 equals p. Now, since I have a p squared and a p, I want to get everything to one side where the p squared is positive. So I'm going to move this over to the other side, so I get p squared minus p minus 2 equals 0. Now I can solve by factoring. I want two numbers that multiply to make negative 2 and add up to negative 1. So two numbers that multiply to negative 2 and add up to negative 1, that's negative 2 and 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So my factored form is p minus 2 times p plus 1 equals 0. Now that gives me two solutions. P equals 2 and p equals negative 1. Okay, now something I have to look out for is that when I have a positive base, I have to have a positive argument. If I put 2 into this argument, I get 2 squared minus 2. Okay, and 2 squared is 4 minus 2 is 2. So I get a positive argument. If I put a 2 in for this p, I have a positive argument. So this 2 checks out. Okay, so if I put in a negative 1, I get negative 1 squared is 1, minus 2 is negative 1. Now I have a negative argument. Okay, so I cannot keep that negative 1 because it gives me a negative argument. Okay, always take your answers and plug them back into the original and make sure you have a positive argument. Okay, next one. Once again, I have equal logs with equal bases. Therefore, the arguments are equal. X squared equals 4x minus 3. Okay, so now I've got an x squared and an x. I want to move everything to one side where the x squared term is positive. So these are going left. X squared minus 4x plus 3 equals 0. And I need to factor, so I need two numbers that multiply to 3 and add to negative 4. In order to multiply to positive 3 and add to negative 4, I'm going to have to use negative 3 and negative 1. Negative 3 times negative 1 is positive 3. Negative 3 plus negative 1 is negative 4. So I have x minus 3 times x minus 1 equals 0. So my two solutions are x equals 3 and x equals 1. Now, if I plug in this 3, 3 squared is 9. That's positive. Okay, so that's good so far. 4 times 3 is 12. Minus 3 is 9. That's positive. So 3 checks out. If I put in a 1, 1 squared is 1. That's positive. 4 times 1 is 4. Minus 3 is 1. That's also positive. So 3 gives me a positive argument on both sides. 1 gives me a positive argument on both sides. So I get to keep both solutions this time. Okay, next up, solve using some more properties of logarithms. So now I've got some condensing to do. First, I've got a coefficient here. This coefficient can be rewritten as an exponent. So I've got log base 5 of x cubed minus log base 5 of 4 equals log base 5 of 16. Now I've got two logs at the same base, and they are subtracted. That can be condensed to a single logarithm, log base 5, and since I'm subtracting, the arguments are divided. X cubed divided by 4 equals log base 5 of 16. Okay, now, equal logs, equal bases, x cubed over 4 equals 16. Okay, so I can multiply both sides by 4, and 16 times 4 is 64, so x cubed equals 64. And in order to get rid of that cubed, I can do a cubed root. Okay, so the cubed root of 64. So option 4 is a cubed root. Cubed root of 64 is 4. So x equals 4. Now, does that give me only positive arguments? The only argument with a variable is here. Put a 4 here. I've got a positive argument. That checks out just fine. Okay, now I've got log base 4 and a log base 4. I can condense. They are added. So I've got log base 4 of, and I'm going to multiply the arguments. X times x minus 6 equals 2. Okay, now this time I do not have a log base 4 on the right side. So what I'm going to do is use a base 4 on both sides. So it's 4 raised to the power of log base 4 of x times x minus 6 equals 4 to the second power. Those cancel. So I get x minus 6 equals 4 to the second power. X times x minus 6 equals 4 to the second power, okay, which is 16. Okay, so now I can distribute x squared minus 6x equals 16. And I can bring this 16 over to the left side. X squared minus 6x minus 16 equals 0. And now I am going to factor. Multiply to negative 16, add to negative 6. So we need two numbers that multiply to negative 16 and add to negative 6. I believe those numbers will be negative 8 and positive 2. Negative 8 times 2 is negative 16. Negative 8 plus 2 is negative 6. So my factored form is x minus 8 times x plus 2 equals 0. And that gives me two solutions. X equals positive 8 and negative 2. Now when I use that positive 8, that gives me a positive argument here of 8. And then here is 8 minus 6, which is 2. And that's also positive, so that works. When I put in a negative 2, I'm going to have an argument of negative 2, and I can't have a negative argument, so I'm going to have to throw out that solution. So x equals 8 is the only valid solution. Okay, then I have 3 to the x power equals 11. What I would do with this one is put it in log form. So I've got log, the base is 3, the argument is 11, the exponent is x. Okay, so log base 3 of 11 equals x. Now I can use that change of base formula. Okay, so that change of base formula is log of the argument divided by log of the base. Okay, so log 11 divided by log 3. Okay, so we get 2.1826. And you know what? After that 6 is a 5, so I'm actually going to bump that 6 up to a 7. And then 5 to the x equals 62. That's log base 5, argument 62 equals exponent x. So that's log of the argument divided by log of the base equals x. So log 62 divided by log 5. So x equals 2.5643, and after that 3 is another 3. That's not big enough to bump that up. So there's my final solution.